In this video, we're going to solve question 22 of the 2021 Junior Mathematics Olympiad first round. We're told that we have a triangle ABC such that the two side lengths AB and BC are equal and they have the length 10, and then the length of side AC is 12. And we're asked to find the circumradius of this triangle given that the in radius is 3. So let me start by talking about what the circumradius of a triangle is. So let's say that we have a triangle that is inscribed in a circle. So we have something like this. So we have a triangle in a circle. So the radius of the circle that passes through all 3 points of a triangle is the circumradius of that triangle. So here we have a triangle, this triangle here, or maybe I should mark that out in red. So here we have a triangle here, marked out in red. And then that circle around it passes through all the 3 points of this triangle. The radius of that circle is what we call the circumradius of this triangle that was circumscribed. So that's what the circumradius of a triangle is. Here, now let's return back to the question. We're told that we have a triangle ABC, so we'll start by drawing that. And then we're told that AB equals BC. So that's kind of like an isosceles triangle that we have. So I'll draw something like this. So I'll call this point B, and call this one A, and this one C. Then we're told that AB and BC are 10. So here we have 10, here also we have 10. And we're told that AC is 12. 12, right? Okay, so in solving this question, we're going to make use of a formula that relates the area of a triangle, the length of the sides of a triangle, and the circumradius of a triangle. That formula is the formula A equals ABC over 4R. So if you know the length of all 3 sides of a triangle, and you know the circumradius of that triangle, then you can find the area of that triangle. So you can multiply the 3 side lengths together and divide by 4 times the circumradius of that triangle, and that will give you the area of it. So this is what we're going to make use of in solving this question that we have here. So the first thing we're going to do is we're going to find the area of this triangle that we're given in this question. Okay, so since this triangle is an isosceles triangle, if we draw a perpendicular bisector from this point B down to AC, it's going to divide the line or the segments AC into 2 equal segments, into 2 equal parts. And so if we draw this perpendicular bisector, here we're going to have 6, like the length from here to here. Let me call this point here M. So the length AM is going to be 6, and the length MC is also going to be 6. And then remember, the formula for the area of a triangle is also half base times height. So that's why we're going about it this way. We're trying to find the height of this triangle and then use that to find the area of this triangle. Okay, so if you look at ABM, you see that we have a right angle triangle here, right? Since we have 90 degrees here. So we can make use of the Pythagoras theorem in triangle ABM. And if we do that, so we'll have that AM squared equals AM squared plus BM squared equals AB squared. And AM squared is 6 squared, which is 36, plus BM squared equals AB squared, which is 100. Then we'll have that BM squared equals 100 minus 36, and then that BM squared equals 64. And then when you take the square root of both sides, you have that BM equals 8. So that means that BM here is 8. And since we know BM and we know the length AC, we can find the area of this triangle ABC. So the area of this triangle here, that's area A. Let me use A for that. So the area A of this triangle is equal to half of the product of the base and the height. And we know that AC, the base here, is 12. So that's going to be 12 times the perpendicular to that base, which is 8. Since we know that here is 8. So that's going to be half times 12 times 8. And here we're going to have that A will be 48. So 48 is the area of the triangle ABC here. And since we know the area of the triangle now, that means that we know the length, the value of A here. We know what A, B, and C here are. And we also, yes, and using that now we can find R here. So let's go ahead and do that. So let me write down this formula again. This formula that relates the side lengths of a triangle and the second radius of that triangle and the area of that triangle. So this is it. A equals ABC over 4R. In this triangle, we know that the area is 48. So we're going to have that 48 equals ABC is the product of a side length of this triangle. So we have three sides of length, 10, 10, and 12. So this is going to be 10 times 10 times 12 divided by 4 times the radius. And then we can just cross multiply and continue from here and see what we get. Oh, before that, we can cancel 4 here to have 1 and cancel 12 here to have 3. So when we cross multiply, we'll have that 48R equals 3 times 10 times 10. And then you can divide both sides by 48. So you have R equals 3 times 10 times 10 divided by 48. And 3 goes once into 3 and 16 times in 48. So you have that R equals 100 divided by 16. Then 4 goes into 100 25 times and 4 times into 6. So we have that R equals 25 over 4. So that means that the second radius of this triangle that we have here is 25 over 4. So this is how to go about solving this question. Remember, the second radius of a triangle is the radius of the circle that passes through all 3 points of that triangle. So that's how this question is solved.